It's natural for students to wonder how they will benefit from the study of programming language concepts. After all, there's so many other topics in computer science that are worth serious study. So, to begin to understand why we want to study programming languages in general, let's discuss a few of the reasons why we want to study these concepts of other languages. The first reason to study concepts of programming languages is the increased capacity to express ideas. It is widely believed that the depth at which people can think is influenced by the expressive power of the language in which they communicate their thoughts. Those with only a weak understanding of natural language are limited in the complexity of their thoughts, particularly in depth of abstraction. In other words, it is difficult for people to conceptualize structures that they cannot describe verbally or in writing. Programmers in the process of developing software are similarly constrained. The language in which they develop software places limits on the kinds of control structures, data structures, and abstractions they can use. Thus, the forms of algorithms they can use and construct are likewise limited. Awareness of a wider variety of programming languages features can reduce such limitations in software development. Programmers can increase the range of their software development thought process by learning new language constructs. It might be argued that learning the capabilities of other languages does not help a programmer who is forced to use a language that lacks those capabilities. But that argument really doesn't hold up because often language constructs can be simulated in other languages that do not support those constructs directly. For example, suppose you were asked to program in a language that does not support stacks and stack operations. One could simply program those or simulate those constructs using arrays and functions that operate on arrays. In other words, the study of programming language concepts builds an appreciation for valuable language features and constructs and encourages programmers to use them, even when the language they are using does not directly support such features or constructs. Improved background for choosing appropriate language is another reason for studying concepts of programming languages. Many professional programmers have had little formal training in computer science. Rather, they have developed their programming skills independently or through their company's in-house training programs. These training programs often limit instruction to one or two languages that are directly relevant to the current projects of the organization. Many other programmers received their formal training years ago. The languages that they learned then are no longer being used today, and many features now available in programming languages were not widely known when they studied that language. The result is that many programmers, when given a choice of languages for a new project, use a language with which they are most familiar, even if that language is poorly suited for the project at hand. If these programmers were familiar with a wider range of languages and language constructs, they would be better able to choose the language with the features that best address the problem. Now, some features in one language, as I said before, can be simulated in another language. However, it is preferable to use a feature whose design has been integrated into a language than to use a simulation of that feature, which might often be less elegant, more cumbersome, and less safe. Another extremely important reason for studying concepts of programming languages is that it increases your ability to learn new languages. Computer programming is still a relatively young discipline, and design methodologies, software development tools, and programming languages are still in a state of continuous evolution. This makes software development an exciting profession, but it also means that continuous learning is essential. The process of learning a new programming language can be lengthy and difficult, especially for someone who's comfortable with only one or two languages and has never examined programming languages concepts in general. Once a thorough understanding of the fundamental concepts of languages is acquired, it becomes far easier to see how these concepts are incorporated into the design of a new language that's trying to be learned. For example, A programmer who understands object-oriented programming concepts will have a much easier time learning Java than those who have never used those concepts. The same phenomena occurs in natural languages. The better you know the grammar of your native language, the easier it is to learn a second language. Furthermore, learning a second language has the benefit of teaching you a little more about your first language. Well, the literature and surveys state that Java, C, and C++ are the three most popular languages in use today. However, the emergence of new languages like Ruby, PHP, Perl, JavaScript have really muddied the water. And the distribution of the use of these new languages is always changing. The number of languages in use and dynamic nature of these statistics imply that every software development must be prepared to learn different languages. Finally, it is essential that practicing programmers know the vocabulary and fundamental concepts of programming languages so they can read, understand program language descriptions, evaluations, and promotions for new languages. Another equally important reason for studying concepts of programming languages is that it allows you to better understand the significance of the implementation of language constructs. In learning the concepts of programming languages, it is both interesting and necessary to touch on implementation issues as they affect those concepts. In some cases, an understanding of implementation issues leads to an understanding of why languages are designed the way they are. In turn, this knowledge leads to the ability to use a language more intelligently, as it was designed to be used. We can become better programmers by understanding the choices among programming constructs and consequences of these choices. Certain kinds of program bugs can be found and fixed only by programmers who understand the underlying implementation details. For example, a runtime error that states Stack Overflow can be easily understood by a programmer who understands how a programming language implements recursion. They might not have used a stack in their program, but might have inadvertently made a recursive call. Another benefit of understanding implementation issues is that it allows us to visualize how a computer executes various language constructs. In some cases, some knowledge of implementation issues provides hints about the relative efficiency of alternative constructs that might be chosen for a program. For example, programmers who know little about the complexity of the implementation of subprogram calls often do not realize that a small subprogram that is frequently called can be highly inefficient in its execution. Another reason for studying concepts of programming languages is that you can better use languages that you already know. Many contemporary programming languages are large and complex, and it is pretty uncommon for a single programmer to know all there is to know about the features of a language that he or she uses. But by studying the concepts of programming languages in general, programmers can learn about previously unknown and unused parts of languages that they already use and begin to use these features very efficiently. The final reason for studying concepts of programming languages is an overall advancement of the field of computing. Although it is usually possible to determine why particular programming languages became popular, many believe, at least in retrospect, that the most popular languages are not always the best available. In some cases, it might be concluded that a language became widely used, at least in part because those in position to choose languages are not sufficiently familiar with programming language concepts. The slide presented to you at this point might be a bit confusing. I just stated recently or earlier that C++, C, and Java are the most used programming languages today. However, you can see here from this particular diagram that A survey of programmers and software developers say that the one language that they like the most is Python. In general, if those who choose languages were well informed about the constructs of programming languages, perhaps better languages would eventually squeeze out poor ones. So let's review the reasons for studying concepts of programming languages. First, we noted that studying concepts of programming languages increased one's ability to express ideas. The skill of programming is a combination of the ability to conceive of information solutions, but also to be able to express those solutions in code. Improved background for choosing appropriate languages. Too often, languages are chosen for many arbitrary reasons. Languages to suit the problem should be the thing that rules that decision. Increased ability to learn new languages. By learning general concepts of languages, one can apply those concepts as one goes about learning new languages, which we all must continue to do. We must all have a better understanding of the significance of implementation to support debugging, to help us design code that is efficient and small in size. We can also use the study of concepts of programming languages to better allow us to understand the languages that we already know by helping us discover new constructs in our existing languages that will help us write better code. And finally, for the overall advancement of computing. The more decision makers know about the basic concepts of programming languages, the better our solutions will be able to fit our problems. Complete the next set of questions and exercises, and this will take you to the end of task 1.1.